Words to know. Ordered pair. Plant. Line graph. Coordinates.
All right. First of all, when you have a line graph, you put it on an axis. You have an x-axis, which is marked right here. An x-axis runs horizontally. Your vertical axis is your y-axis, which is labeled with a small y. Notice that your graph will have a title, although this one doesn't show one here. It will have a title, just like your line plot, just like your frequency table does. Also has your axes labeled, just like a frequency table is labeled, just like a line plot is labeled, okay? An ordered pair goes X, Y, X, Y. And you can remember that X comes first in the alphabet. So X is your first number in your ordered pair. Y is the second value in your ordered pair. And so just like X comes first, whenever you find or plot that coordinate or ordered pair on the line, on the graph, you go over X and up Y. You do the X-axis first. So X-axis, I need 1, which is right here. Y-axis, I need 4, so I go up 4 and plot the point.
How can this data be represented? Think about this question during the lesson.
Okay, so what is this right here that they've given us? A frequency table. I'm sorry, yes.
This table shows the growth of a plant over a period of several days. The data can be displayed on a line graph. A line graph is often used to show a trend or general direction in data.
Okay, so trend meaning, does the data seem to always be going up, increasing? Does the trend seem to be going down, decreasing? You see an example of this whenever your SRI reports are sent home. There's a line graph there. You can see your trend. Is it going up? Or is it going down? Or does it seem to be a flat line, meaning staying the same?
How do you know to use a line graph with this data? The data table includes data with a unit of time. What other situations showing a change over time could be shown with a line graph?
So they say a line graph can be used when time is involved.
Some other situations that can change over time could include how tall you grow each year, the dollar amount of movie ticket sales each week, or the outside temperature throughout the day. What are some units of time that you may have learned? Some units of time that you may have learned are seconds, minutes, hours, days, weeks, months, years, or specific hours like 1 o'clock, 2 o'clock, etc. Look at the data in the table for the houseplant. Think about how you can display this data on a coordinate grid.
Coordinate grid meaning the grid, the XY grid with the boxes.
Draw a coordinate grid. Use an appropriate scale and label each axis.
Okay, so we have X-axis here, Y-axis here. We're going to label one of them day and one of them height in centimeters.
What coordinates go in the bottom left corner of your grid? This is the origin, 0, 0. So label the bottom left corner of your grid 0.
Okay, does that make sense? It's called the origin. It's where it starts out. This is coordinate 0, 0. Your X is 0 because you went over 0. Your Y is 0 because you went up 0. So you always label that one 0.
Which unit is labeled on the X-axis? The unit of time in days is the label on the X-axis. Which unit is labeled on the Y-axis?
So this is day. They made this the x-axis because it's the first values in the frequency chart here. So the y values are going to be right here. So what label is that y-axis going to get, Alex?
I had a question.
Okay, but can you answer that for me? What label is this y-axis going to get?
1, 2, 3, 4.
Well, those are the numbers, but what label?
Height.
Yes, height in centimeters. That's going to be your label here. What was your question, Alex?
Is it X, then Y? Or
Yes, just like in your alphabet, X comes first, then Y. So X, Y, X, Y, X, Y. So 1 and 4 are going to go together, meaning you'll go over 1 on the X, now the Y, up 4. Then 3 and 8 go together. Every time you start at the origin, you'll go over X3 and up Y4. I'm sorry, 8. 3 and 8 are together. Over 3 and up 8.
The height of the plant in centimeters is labeled on the y-axis. Is it important to number the x-axis showing equal amounts of increase? Yes, if you do not number it evenly, the graph will not look correct.
Okay, so you have to have equal number of increase, which means your intervals need to be all the same. So I can't say 1, 2, 5, 7, 10, okay? If you're going to intervals of 1, then it needs to be intervals of 1 all the way through. Intervals of 2, it needs to be intervals of 2 all the way through.
Does the y-axis have to be labeled with the same numbers as the x-axis?
Well, look what they did here. They went in intervals of 2 here, right? But they went in intervals of 1 here. So that tells us no.
No, the labels on the y-axis do not have to be the same as the labels on the x-axis. However, the numbers do have to increase in equal amounts to ensure that the graph shows the data correctly.
Okay, so the same thing here. Your intervals need to be equal throughout. You can't go 2, 4, 10, 17. Okay, your intervals need to be equal, because if you don't, you may show a huge jump and then a small jump, when really that may not be the case.
Plot each ordered pair from the table.
Plotting the points is literally putting the points on the grid. That's called plotting points. Sorry.
How do you plot the numbers in the chart as ordered pairs?
Okay, so we know 1, 4 is an ordered pair. We go over 1, up 4, put a dot right there at the corner where they meet. Then we know 3, 8 is an ordered pair. 3 is my X, I go over 3. 8 is my Y, I go up to 8. Right there at the corner, I put a dot, a point. Over 5X, up 10Y, plot a point. Once I have all my points plotted, then I will get my ruler and connect them.
The time, day, is the x value, and the height, centimeters, is the y value. How would you name the coordinates of the first ordered pair? The coordinates of the first ordered pair would be 1, 4. What symbol do you use to plot the point on the coordinate grid?
A dot.
You will use a dot to show the point. 1, 4. Plot all the ordered pairs on the grid.
Okay, notice your dot, when you plot this point, needs to be visible, meaning it needs to be more than a speck, okay? But it does not need to be a dot that has been colored in over and over and over this big, okay? Because your boxes on your grid aren't very large, and if you put some large honking dot in there, it's going to be hard to know exactly what point you've just plotted, okay? So again, neatness.
Use a ruler to connect the points.
Okay, so what they did is they used the ruler to connect from here to here. Then they move their ruler here to here. They move it again here to here. We can see what is the trend with this graph. Daniel, what's the trend? Increasing or decreasing? Increasing. From the beginning, from 0, 0 on, it's going up. It's increasing.
Why is it important to use a ruler to connect the points? The connected points in a graph show the trend in the graph more clearly. What does the shape of the graph tell you about the plant?
That it is increasing in height.
The graph shows that the plant is slowly growing taller. Now you know how to represent data in a table on a line graph.
So we have this sheet here. We have information, data here. We need to put it on our graph over here, our line graph. We're making the line graph is what we're doing. And so we need to title it though. We know that it has to do with time, something that happened over time, which is what the video suggested is when you can use a line graph. Now it doesn't have to just be days, maybe it's over months, maybe it's over a couple hours a day in the same day, maybe it's over years, okay? But anything that involves time. So we need to put a title here above our data in our frequency table. And so it's over a course of 5 days here. Every day they logged their miles. So what could we call this title? What do you want to call it, Corinne? Miles Road or daily mile log or something like that, you know, like a journal people keep. So I'm going to call it daily mile log. So since that is the title on our frequency chart, it's also going to be the title of our line graph. Daily mile log. So, because these come first, the days, they're going to be what? Our X or our Y, Braxton? These values will be the X. I'm going to put the X right here. The miles byte comes second, so they will be our Y. That means when we have ordered pairs, X, comma, Y, for our first day, our order pair is going to be 1, comma, 6. When you write them, you put them in parentheses like just to let you know. You put a comma between them to separate them so it doesn't look like 16. For our day 2, our second point we have to plot, the coordinates will be 2, 4. 2, comma, 4. Our next point will be 3, comma, 7. Then 4, comma, 8. And 5, comma, 10. These are the points that we're going to have to plot over here on the chart. Now, our labels are not here, our vertical and horizontal labels. We have the title. What comes on the x-axis? What label should that be? The horizontal label. What should it say? Cayenne, what should it say?
It should be the horizontal.
For X, days. Because I know that because days are my X's in my chart. They came first here. They're my X values. So the X values are going to say be labeled days. Day. And so the vertical is the up and down label, which they don't have a line for us here. Right here, I know, but I'm going to put it here because normally you see it here. I'll write it both places. But my vertical label is going to then be the Y, stands for miles biked. If you do not have your labels, your graph is incomplete. Just like with a frequency table, just like with a line plot, you have to have your labels. All right, now we're ready to start plotting our points. X is 1, so we go start at 0, 0. We go over 1 on the X, and the Y we go up to 6. And plot our point with a neat dot. Next one, X we need to go over 2, and now up 4. Plot our point. Huh? Yes, because it's a 4 for our y.
Oh, okay.
Our next point, we go x 3